While there is awareness of global climate change among Sri Lankans, the response of youth and community is held back by lack of awareness of local climate change, understanding of the regional seasonal changes in climate, and the evidence to attribute climate change locally. We address these gaps and we present some basic information on climate of Sri Lanka. There are four main mechanisms that shape Sri Lankan climate and the manner in which these mechanisms affect the seasonal and regional Sri Lankan climate. Seasonal variation of solar radiation and wind circulation. Impact of the South Asian Indian Ocean monsoon. Impact of mountain-induced rainfall. Impact of cyclonic storms. The air above the Earth forms a thin layer around the Earth's surface which is referred to as the atmosphere. This thin gaseous layer supports present forms of life and it helps maintain the Earth at a stable temperature. The climate system as presented here captures the way in which atmospheric conditions are affected by land, ice masses and oceans and their impact on Earth's surface. Note, the word climate is used loosely to refer to long-term conditions at any place that exceeds a few days. The climate system has natural time scales of days and seasons related to the rotation and revolution of the Earth. We shall use the following terminology: weather, climatology, climate variability, climate change, near-term and long-term. The first significant mechanism that shapes the Sri Lankan climate is the seasonal variation of solar radiation and wind circulation. The climatology at any location is driven by solar radiation, which varies as the Earth rotates on its own axis and the time it takes for the Earth to orbit around the Sun. The chart shows the average solar radiation received at any latitude around the Earth. The latitudes closer to the equator receive more incoming radiation than is radiated back to Earth. The latitudes closer to the poles garner less incoming radiation relative to the outgoing. This imbalance within the climate system results in an equator pole circulation system so as to set up thermal equilibriums. The climate system balances the thermal imbalance by a north-south circulation system. Due to reasons of stability, this north-south circulation system is broken into three cells. In the next graphic, a cross-section of the northern Hadley lower half cell is shown. The closest to the equator is named after Hadley, and here warm moist air rising in the tropics spread to north and south. The monthly variation of rainfall is shown across the Earth based on observations for 30 years. The monthly variation in the bottom left corner and east-west band of rainfall migrates between southern tropics and the northern tropics. This band is a consequence of rainfall associated with the tropical convergence zone. Note that this rain pattern is modulated with southern Asia by the monsoon system. Shown here is a blow-up of the monthly rainfall in shades of green near Sri Lanka. Also shown are the monthly average wind vectors, the direction being shown by the arrow and its size reflecting the speed. Note that the wind directions reverse during April and November. The speeds are highest around July. During May and November, Sri Lanka receives the highest rainfall. The second significant mechanism that shapes the Sri Lankan climate is the impact of South Asian Indian Ocean monsoon. While the Hadley cells drive the basic climatology of the tropics, in some region it is modified by the monsoon. Monsoons are often simply confused with rainfall. That is misleading and causes much confusion in Sri Lanka. A monsoon occurs in regions where mountains or highlands exist near bodies of water that have tropical characteristics. During the summer months, the land heats up more than the water, creating an area of low pressure over the land and high pressure over the water. This means winds rich in tropical moisture travel on shore. Upon encountering the mountains and highlands, the moist air is forced upwards and develops into clouds that dump heavy rainfall. The monsoon circulation modifies the Hadley circulation over Sri Lanka. Sri Lanka is more to the sea. Sri Lanka's rainfall is suppressed during the June to September period and enhanced in November-December to January rainfall. The third significant mechanism that shapes the Sri Lankan climate is the impact of mountain-induced rainfall. While the Himalayas induce the monsoon, the mountains in Sri Lanka affect the spatial variability of rainfall and wind, and this mechanism is shown graphically in the schematic. There is an anchor-shaped mountain providing a central spine to Sri Lanka's southern half. Humidity is generally high in Sri Lanka. As a result, the orographic rainfall mechanism causes high rainfall during high winds on the windward side. From June to September, during the periods of strong westerlies, there is high rainfall on the western slopes. From December to February, the moderate winds arriving from the northeast leads to enhanced rainfall on the eastern slopes. The southern half of Sri Lanka has an anchor-shaped mountain with a central spine. The Knuckle mountain range lies at a slightly angle to this spine. Temperature drops with elevation. In addition, orographically modified winds lead to regional disparities. For example, in July, Batticaloa is warmer than Colombo. In January, Colombo is warmer than Batticaloa. Sri Lanka has stark regional variation primarily due to the orographic mechanism. During July, westerly winds lead to heavy rainfall, 10 to 20 kilometers as the windward side of the mountains. During January, the easterly wind leads to the rainfall in the eastern slopes. The fourth significant mechanism that shapes the Sri Lankan climate is cyclones and cyclonic storms. Cyclone is a system of winds rotating counterclockwise in the northern hemisphere around a low-pressure center, resulting in strong winds and intense rain. Storms that do not reach the required speed of a cyclone is called a cyclonic storm. Cyclonic storms layer affects the northern, eastern and north-central region and cause heavy rainfall from November to January. After introducing the different time scales of interest of the climate system, we focused on the climatology. The passage of the Hadley cells, driven by the varying seasonal solar radiation, is the primary driver of climate in Sri Lanka and yields warmer temperatures, wind reversal, high rainfall when the tropical convergence zone is above Sri Lanka. The monsoon system enhances the end of the year rainfall and diminishes the mid-year rainfall in Sri Lanka. Mountain-induced rainfall drives strong spatial modifications of climate. Temperature drops with elevation falling approximate 6.5 degrees for every kilometer approximately. Orographic rainfall augments the rainfall on the western slopes and plains of Sri Lanka from May to October and the eastern slopes from December to January. Cyclonic storms lead to extreme wind and rainfall in the eastern and northern provinces, and these are experienced from October to March. We hope this video helps you to understand mechanisms that dominate Sri Lankan climate and to use that understanding to interpret the regional and seasonal variation of climate.